So scatter plots are graphs that show the relationship between sets of data, and they're shown by points that are on the graph. So this graph right here is an example of a scatter plot. So in this particular graph, it says it shows the amount X in grams of sugar and the number Y of calories in 10 different smoothies. So it asks us to identify the independent. It's important to know that our independent is our X's, which it told us in our problem that X was our sugar. It also told us on the graph that the X-axis was represented by the sugar grams. So our independent variable in this case is our sugar. Our dependent variable is going to be our Y's, which it told us in the problem was the number of calories. It also told us over here on the graph that it was the calories. So my dependent is my calories. The question asks how many calories are in this smoothie that contains 56 grams of sugar. So we're going to go to 56 down here on the sugar grams, which is going to be between 54 and 58, and go up, and there's a point. And if we go over, that tells us that there are 270 calories in that particular smoothie. Part C asks how many grams of sugar in this smoothie that contains 320 calories. So the same process, but we're starting over here at the 320. Going over to the graph, well, there's my point, and if I go straight down, I end up at 70. So there were 70 grams of sugar in that particular smoothie. And then what happens to the number of calories as the number of sugar grams increases? Well, if you look at the graph, you can see that as the grams of sugar is increasing, my calories are also increasing. So they also increase. Which leads us to the different types of correlation. So there are 3 types of correlation. We can have positive correlation, which is going to be correlation that goes up. We can have negative correlation, which is correlation that goes down. Or we can have no correlation, which is where the points are all over the place. When we have positive correlation, what that means is that both sets of data are increasing. So I want you to write that both go up. So both sets of data are going up. If we have negative correlation, the reason we have negative correlation is because as X increases, Y decreases. So I want you to write underneath that one goes up and one goes down. And lastly, if we have no correlation, then that's because the data sets are not related, so they're just points all over the place. So for every graph that has correlation, so either positive or negative correlation, we can draw what's called a trend line, or what's also called a line of best fit. A line of best fit. And this is a line that's drawn on the graph that illustrates the direction the points are going. And when we draw our trend lines, typically about half the points are below the graph and half are below the line, and the other half are above the line. Sometimes they're even on that line. So I've drawn my 2 trend lines here, both of them in pink. To give you an example of these are both good trend lines because they go through the middle. A bad trend line, I'm about to draw this. So I'm going to draw the bad one in black. So a bad trend line, you don't have to write this, but a bad trend line would look like this. Notice it doesn't really follow the data, or an example would be like that. Neither one of those follows the data, so they would not be good trend lines. It's important to note the reason we draw trend lines is that they are used to make predictions. Trend lines are used to make predictions. we're going to talk first of all about just different types of correlation. So if you look at number 2, it gives you a situation, birth month versus hours of sleep, and we have to decide if there's positive, negative, or no correlation. Well, my question for you is there a relationship between what month you were born in and how much sleep you're going to get? The answer to that question is no, so there's no correlation in that data. Looking at number 3, it says the temperature and coat cells at a store. So the first question we ask ourselves is there a relationship between these two topics? Well, if you think about it, yes. And if we were to describe the relationship, then what you would tell me is that as the temperature goes down, the coat cells are going to go up. So notice that one is going down and one is going up. Well, that was one of the definitions we gave for negative correlation. So this particular situation has negative correlation. If you look at number 4, it talks about the gallons bought and the amount of money spent. Well, if you look at the numbers, this will help you figure it out. So we have 4, 10, 14, 18. These numbers are increasing. So I'm actually going to write that increasing. I'm just going to write I and C. And then if we look at the amount spent, well, it's going 14.2, 35.5, 49.7, 63.9. So these numbers are also increasing. So they're both getting bigger, they're both going up, and that was the definition of positive correlation. Number 5, if we look at this graph, you can see these data points. If you'll notice, they're going down, so they're going to represent a negative correlation as well. So for number 5, we're actually going to need our calculator, so please make sure you have it, and you're going to need to follow along very closely so that you can understand what we're going to be doing here. We'll get to that with the calculator part in a second. So 5 says the table shows the weekly sales of a DVD and the number of weeks since its release. So we have this table, and if we just look at it, if we look at our x's, they're going 1, 2, 3, 4, 5, 6, 7, 8. So my x's are going to be increasing, so they're going up. If we look at our y's, it's 19, 15, 13, 11, 10, 8, 7, 5. So these are going down. And we learned that if one of our values is going up and the other value is going down, that's going to be a negative correlation. So we've already answered question C. Well, question A asked us to make a scatter plot of the data. So we're going to do that next. Before we can start graphing, you need to make a correction to the graph. If you'll notice on the left-hand side, on the y-axis here, I labeled this incorrectly. It should be 3, 6, 9, 12. This should be 15. The next number should be 18, and then it should be 21. And now we're going to be able to plot our points. So if we look at the table to our left, the first ordered pair that it gave us was the ordered pair 1, 19. So I'm going to go all the way up here to 19, which is going to be between 18 and 21. It is going to be closer to 18, so we're going to put a point there to represent the weekly sales in week 1, which was $19 million. The next point it gave us was 2 and then 15. That's going to be right here on this line. Then it gave us 3 and 13. Well, 13 is going to be between 12 and 15. It's going to be a little closer to 12, though. The next point was 4 and 11. That's going to be between 9 and 12. It's going to be closer to 12, though. So it would be here. Remember, all these points are just coming from the table. So just looking at the table, notice that our next point is going to be 5 and 10. So 5, 10 would be about here. And our next point is going to be 6, 8. So we're going to go over to 6 and go up to 8, which is going to be about here. Our next point is 7, 7, which would be here. And our last point is 8, 5, which would be here. So we have now plotted all of our data. So we did part A. Now we're on to part B. Can the data be modeled by a line? Which doesn't mean that it's perfectly linear, because this right here, these points are not a perfect line. They're kind of close, but not really. But it can be modeled by a line because it has negative correlation. So yes, because it has negative correlation.
So we're supposed to, for part D then, because we did part B now and we've done part C, part D says to draw a line that appears to fit the data most closely. So this means we're going to be drawing our trend line. So remember, our trend line is not going to go through all of our points, but it's going to probably touch some of them. So a good trend line would look something like this one where the pink is following. So I cheated a little bit and I actually used a straight line that's already on this iPad app to draw my line, but notice here's my trend line. So it goes through, it touches a couple of the data points, but some of the points are above the line, some of the points are below the line. This just kind of estimates where the line would be. So you need to make sure that you draw your trend line. So that's done. So part E asks us to write an equation that models the DVD sales as a function of the number of weeks since its release using the points 5, 10. So this is where we're going to start using the calculator. So I'm going to make a note of this, calculator. Anytime it asks you to write an equation, you're going to be using the calculator. And this is true for both the sets of notes that we're doing.
Before we can actually use the calculator, we need to make sure we reset the memory. So go ahead and turn your calculator on, and then I want you to press second plus 712. Again, that was second plus 712, and that's going to clear our memory out for us and reset our calculator to make sure it's ready to go. So to type this in the calculator, we're actually going to use the stat button, which some of you guys learned how to use this in middle school. So if you'll press stat, which is right underneath delete, and then we're just going to hit enter because we want to go ahead and edit, and you'll see a screen that looks like this. And notice that here in these in this table, we have a list 1 and we have a list 2. And what we want to do is we're going to take our points, which are currently an X and a Y, and we're going to translate them into L1 and L2. So my first point was 5, 10, and my second point was 6, 8. So I'm going to type those in my calculator. So on the left side in L1, I'm going to put 5 and 10. And then on the right side, 5 and 6. And then on the right side, I'm going to put 10 and 8. Once you have those typed in, then you want to go back to stat, go over the top to calculate, and you want to go down to number 4. It's important to understand why we press 4, because we're talking about trend lines, so we need to make sure we're getting the equation of a line. And notice that number 4 here says len reg. So we want to press enter, and then enter several more times, and it's going to take us to a new screen. And this screen right here is going to give us the equation of our line. So based on what we have here, it says y equals ax plus b, and it tells us a is negative 2 and b is 20. So that means that our equation of our line is y equals negative 2x plus 20. This is the equation that we're going to work with. So in this particular equation, my slope is negative 2, because remember my slope's always what's attached to x, and my y-intercept is the positive 20. So my y-intercept is always by itself. And when we interpret our slope, remember that slope is always written in the form of something per something else, and it's always our y's per our x's. Well, if we go back and look at our table to look for our units, our y's was our sales in millions of dollars. So this translates our slope as our negative 2, which is going to be our sales per, and our x's represented our week, so it's going to be our sales per week. So that's the interpretation of our slope. Now for the interpretation of our y-intercept. Our y-intercept was 20. And remember, our y-intercept, first of all, it's a y value, so that means this has something to do with sales, so it's money, and it's in sales. And our y-intercept is always where we begin. It's a beginning value, and so this tells us that we began with $20 million in sales. This is the interpretation of our y-intercept. So problem 6, the scatter plot shows the days x of practice and the number y of free throws made during practice. So we're supposed to model an equation that represents the data using the data from days 4 and 5. So they did give me 2 points, although they didn't say specifically what those points were. They gave me day 4 and day 5, and we know that our days were our x's, so we know our x's are 4 and 5, and we can use our graph over here to figure out what those y values are. So if we go to 4 and we find our point and we go over, we're going to find another point at 4. So the first point is 4, 4. And we do the same thing for day 5, which is going to be between 4 and 6. We go up. Here's my next point. Pay very close attention that this point over here is the ordered pair 5, 6. So this is what I'm going to put in my calculator. So we're going to go ahead and clear this out, and we're going to go back to stat because we're just going to put new points in. So stat and edit again. And to clear out these numbers, you want to make sure that you're hitting delete. But notice I'm deleting the numbers. I'm not deleting out what's in L1. So I want to just hit delete, delete, and then do the same thing, delete, delete. And I'm going to put my X's in L1. My X's over here are the 4 and the 5. So 4 enter, 5 enter. And then I'm going to put my Y's in L2, which are my 4 and my 6 for my ordered pairs. So 4 and 6. I'm going to go back to stat, over to calculator at the top, and again I want to choose number 4 because we know this is linear regression. Hit enter a bunch of times, and I get y equals, it says ax plus b, and a is 2 and b is negative 4. So this tells me that my equation is going to be y equals 2x minus 4. So the next part says predict the number of free throws made after 10 days of practice. Well, 10 days tells me that x is 10, and the whole reason that we come up with this equation here, the whole purpose of this is to make predictions. That's why we figure out these equations, is to make predictions. So I'm going to take my equation, which is y equals 2x. I'm going to leave a blank for x, minus 4. Instead of x, I'm going to put in 10 because that's what I know my x value is. And if I work that out, I get y equals 20 minus 4, which is y equals 16. So after day 10, there would be 16 free throws made. So the next part of our lesson is about correlation. So correlation goes into deciding how strong or how weak our correlation is. So remember, we can have positive, negative, and this should say no correlation, not strong, not zero, but our correlation gets a little more specific, and now we're saying that it can either be strong or weak. And what tells us if it's strong or weak is what's called the R value. This R value is going to be very, very, very important. So, and the calculator is going to give that to you. You don't have to find it. So your R value can be anywhere between -1 and +1. The closer it is to 0, the weaker it is. At 0, actually, there is no correlation whatsoever. At 0, there is absolutely no correlation. When it's out here on the ends, between -1 and -0.7, or between +0.7 and 1, it's really strong. So the closer it gets to 1, the stronger it gets. And then when it's in the middle, towards 0, it's going to be weak correlation. So as it goes in, it gets weaker from both directions. So you can have strong negative or strong positive correlation. You can also have weak negative or weak positive correlation. So the closer the R value is to 1 or -1, the stronger it is. And the closer the R value is to 0, the weaker the correlation is going to be. So when we use our calculators to find this line of best fit, or to find the R value, it's important to note you're not going to pay attention to R squared. R squared is not going to be useful to you at all, so you can mark that out. So the line of best fit is our trend line, and from this, our calculator is going to produce this for us. It tells us y equals ax plus b, and it gives us a, so we're just going to round to 3 decimal places, so 0.458 x plus b, which is 2.780. Our R value is 0.950 in this case, so that's going to be really strong because it's really close to 1 and it's positive, so that's why we circle the positive down there. For my next equation, my line of best fit, my A and my B are going to be useful again for that. So it says y equals -0.728 x plus 6.633. So I just took these two values and I plugged them into this equation. And then I look at my R value. Well, it tells me my R value is -0.632. So clearly it is negative. The other thing that we've got to figure out is it's strong or weak. Well, thinking back to our number line, that negative 6.32 would be about here on the number line, and that's in our weak category because strong is anything that's between 0.7 and 1. So this is actually going to be weak correlation. The table shows the duration x in minutes of several eruptions of the geyser Old Faithful and the time y in minutes until the next eruption. So we're supposed to do several things here. We're going to use a calculator to find the equation of the line of best fit, and we're going to interpret the correlation coefficient, which is our R value. Before we can do that, we've got to set our calculator up to give us the R value. In order to do that, the instructions are on the bottom of this particular paper, but I'm also going to show you how to do it. So we're going to press second and 0, and it's going to give us our catalog, and we want to go till we find diagnostic, and we're going to turn the diagnostic on. They are in alphabetical order, so we're going till we see diagnostic, and we're going to go down a little further, and there it is, diagnostic on. We want to hit enter, and it's going to take us to this screen, and we're going to hit enter again, and it tells us that our diagnostic is now turned on. So make sure you turn to your turn to a buddy and make sure that their calculator is set up that way. So now we're going to go back to stat and edit. To get our line of best fit, we're actually going to type in all of these points. Now that's different than before because before we only typed in 2 because they only gave us 2. But this time they didn't tell us which 2 to use, so we're going to do all of them. So I'm going to delete out my numbers that are in L1 and L2. Remember to delete them, I just hit the delete button. And then I'm going to type in my X's, which are 2, 3.7, 4.2, 1.9, 3.1, 2.5, 4.4, and 3.9 again. So all my X's are typed in. I'm going to do the same thing with my Y's, and my Y's over here are 60, 83, 84, 58, 72, 62, 85, and 85. So I've got all those typed in. I'm going to go ahead and go back to stat, over to calculate, and again I want number 4. And this time it's going to give me a lot more data, which is what I want. So it gives me the equation y equals 11.99x plus 35.106. So that's going to be my equation we're going to use. It asks me to interpret and identify the correlation coefficient. Remember, your correlation coefficient is your R value, which is 0.978. So that tells us that there is strong positive correlation because that's really close to 1. So there's strong positive correlation. We're going to skip part C. We're going to look at part D. It says predict the time after an eruption lasting 5 minutes. So if it's lasting 5 minutes, that's telling us that X is 5. So remember, as before, we can replace X in our equation, which was 11.99, and we can replace that X with a 5 because it says 5 minutes is how long we're going to figure out. So plus 35.106, which if you put that in your calculator, it equals 95.056. So we could predict that the next eruption would happen 95 minutes later. So the last part of our lesson is about the difference between correlation and causation. So it's important to note that two things can be correlated, but that does not mean that one thing necessarily causes the other to happen. So for example, the table shows the number of ice cream sales and the number of boating accidents at a resort over a period of several months. So first of all, what is the correlation? Well, if you look at your ice cream sales, you can see that they're increasing, they're constantly getting bigger. And if you look at your boating accidents, they're also increasing, so that tells us that there is a positive correlation. But it's asking you, can you assume causation, which causation means that one is causing the other. That means, does ice cream sales cause boat accidents? And the answer to that question is no. Eating ice cream doesn't cause boat accidents. But I want you to think about this. As the temperature increases, that means there's more people at the beach or at the river or at the lake. And if there's more people at the lake and it's hot, that means they're selling more ice cream. And it also means that because it's hot, there's more boats out there, there's more people in the boats. And that is what is causing the accidents. So while there is a relationship between the ice cream sales and the boating accidents, they do not directly cause one another. So we have number 5 down here. It says the time spent exercising and the number of calories burned. Is there a correlation? Well, yes, there is. The more you exercise, the more calories you burn. So that's a positive correlation because they're both increasing. And in fact, there's also a causation because exercising does burn the calories. There's a direct result there. If we look at 6, the number of banks in the population of a city. Well, the more banks there are, typically the bigger the city there is. So there is a positive correlation. However, there is not a causation because having a lot of banks does not mean that you're going to have does not cause there to be a big population. There's more banks because there's more people, but they're not caused by one another. So down here at the bottom, just notice that I've given you instructions for how to clear your calculator if L1 and L2 aren't there, and how to turn on R, which is our diagnostic, in case you forget.